Good morning, everyone. Welcome back. Today we are going to look at lesson 10. So the expectation is that you are done with lessons 1 through 9 and you have a cheat sheet ready where you are copying all the important information and theorems as we go through these lessons. So if you're done with lesson 9, we are ready to start lesson 10 now. Lesson 10, we are going to go back to inscribed angle theorem. So take a minute, remember what inscribed angle theorem is and what are some of the consequences of the inscribed angle theorem. So the inscribed angle theorem says that if I have a circle and there is an inscribed angle in my circle, so the inscribed angle theorem says that angle B, so angle ABC, is going to be 1/2 the measure of the arc AC, of this arc AC. And one of the consequences of that theorem is that if I have a central angle with the same arc also, and here is my central angle, angle AOC will actually equal the measure of arc AC. So angle ABC is going to be 1/2 of angle AOC. So an inscribed angle is 1/2 the measure of the central angle of the same arc. Now go ahead and do the first problem. You should be able to find all the angle measures on your own. So pause the video here and go ahead and try and do problem 1 on your own. Once you're done, come back and check your answers with my answers. And here are the answers that I got with an explanation of how I did these problems. Again, everyone, remember, if you have questions, you can log them onto the document labeled questions, and you have access to that through the main Google document shared with you on Google Classroom. Okay, so moving on, let's look at example 1 together. Example 1, they're asking me to examine the two diagrams that are shown, and develop a conjecture about the relationship between the measure A and B. Okay, so let's look at the two diagrams carefully. So what I can see is, so angle A is this entire angle. Please understand the measure A is this entire angle CAB is A. So I'm looking at a tangent AB and a secant AC. Now the reason I'm calling it a secant and not a chord is that a chord is just a special kind of a secant. A chord is a line segment that touches the circle in two places, while a secant is a line that touches the circle in two places. So I have a tangent AB and a secant AC. I can see angle CAB with measure A is the angle that is created by this tangent AB and the secant AC at the point of intersection, which is A. And B is the measure of this arc AC. So arc AC, the measure of arc AC is B. And the same thing here. In diagram 2 I'm looking at, I can see that BAC is the angle BAC is the angle that is created by the tangent AB and the secant AC. And B is the arc AC, which is the arc between these two, between the tangent and the secant. So this brings us to now the tangent-secant theorem. It says let A be a circle, A be a point on the circle, and let AB be a tangent ray to the circle, and let C be the point on the circle such that AC is a secant to the circle. So exactly what we are seeing here, I have a circle O and AB is a tangent ray to that circle. AB is a tangent and C is a point on the circle such that AC is a secant to the circle. A is the measure of angle BAC and B is the angle measure of the arc intercepted by angle BAC. And the tangent secant theorem says that the measure of A is going to be 1/2 the measure of B. We're going to now go and prove this theorem. This is a very important theorem. So pause your videos here and note this tangent secant theorem on your cheat sheet, please. It's an important theorem which we'll be using again and again. Okay, so to look at the proof of this theorem, I have a circle with center A. In this case, BG is a tangent and BC is a secant such that they are meeting at a point B. A is the angle that is getting formed between the tangent and the secant, and B is the arc that my secant is creating. So given a circle A with tangent BG, prove what we just discovered using what you know about the properties of a circle and tangent and secant lines. First, they're asking me to draw the triangle ABC. So I am going to connect points A and B and A and C. I know that AB will be equal to AC because these are radii of the same circle. Then what is the measure of angle BAC? So first they want us to find the measure of angle BAC. So let's talk about that. So if I say that, say this angle is angle BAC is going to be B degrees because it is the central angle of the arc BC. So it is going to be angle BAC equals B because this is the central arc of that, the central angle to the arc BC. Now, what is the measure of angle ABG? ABG. ABG is going to be, if you remember, it should be 90 degrees. ABG, this angle should be 90 degrees because tangent is perpendicular to radii at the point of tangency. Next, they are asking us to express the measure of the remaining two angles of the triangle ABC in terms of A. So if A is this angle and the entire angle is 90 degrees, then the angle ABC will equal 90 minus A. This is your angle addition postulate. So, and this is also going to equal angle ACB because these are the base angles of an isosceles triangle are equal. What is the measure of angle BAC in terms of A? Okay, so now we know this angle is 90 minus A and so is this. And we know that the angles of a triangle, the sum of angles of a triangle is 180 degrees. So I know 90 minus A plus B plus 90 minus A is equal to 180 degrees. So if I simplify that, I get 180 minus 2A plus B equals 180 degrees. Simplifying further, I get negative 2A plus B is equal to 0, or 2A equals B, or A equals B over 2. And I have proven my tangent secant theorem. Take a minute, very carefully look at what A is and look at what B is. A is the angle that is getting formed by my secant and tangent to the circle. And B is the arc that the secant is creating. So they're saying that the angle A that is created between the tangent and the secant is going to be 1/2 of the arc that is intercepted by that central angle BAC. Next, we are going to apply this tangent secant theorem to figure out the missing angle measures. So let's look at the first problem. In the first problem, this angle is given to be 34 degrees and this is 52 degrees. And they are asking me to find X, Y, A, B, and or C, whichever is applicable. Okay, so let's start with looking at this 34 is the angle that the tangent FG and the secant BC are making. So this is 34 degrees. So that tells me that this arc is going to be double of that. So this arc is going to be 68 degrees. So if that is 68 degrees, A is the inscribed angle of that arc BC. So A is going to be 1/2 of 68 degrees, which is 34 degrees. Now I can also see that A plus B should be 90 degrees, because this is just Thales' theorem that any angle in a semicircle is a 90-degree angle. So A plus B is 90 degrees. So then B will be 90 minus 34. So B will be how much, people? 56 degrees. B is 56 degrees. Can I find angle C now? C. To find angle C, what can I do? I can see, be very careful, CD is not a diameter of this circle. So please do not think that CD is a diameter. You have to be careful. So I know that this angle is 52 degrees, and this I haven't used yet. So let's go ahead and try and use that. So if that is 52 degrees, then C should also equal 52 degrees. This is also a consequence of my inscribed angle theorem, that inscribed angles of the same arc are going to be equal. And for both this 52 degree angle and angle C, my inscribed arc is this arc BD. So I know this is 52, and so this should be 104. So C should be 52 degrees. Okay, so next problem, actually next couple of problems, 2, 3, 4. Try and do them on your own. And if you want help, just follow along with me. So let's look at number 2. Number 2, again, they're asking me to find A and B. So let's start with, and they're telling me that this angle is 106 degree, which is getting created by the secant BC and the tangent BD. So also I know that AC and AB will be equal because these are radii of the same circle. So this 106 degree angle tells me that, where am I going with this? Okay. I can see that this angle ABD, is a 90 degree angle, and this is just due to Thales' theorem again. So if that is 90 degrees, then I can say that A should be 106 minus 90 degrees, which will give me 16 degrees. So if this angle is 16 degrees, also this is 16 degrees. Do I know how to find angle B? So I know A plus B is 180 degrees because these are sum of angles of a triangle is 180 degrees. So if I substitute 16 for A and I solve for B, I will get B equals 148 degrees. So that is the measure of B is 148 degrees. Moving on to the next problem. Let's go to number 3 together. If you want, you can pause the video and try and do this problem on your own. Again, this is my angle A, here is B, and this angle is given to be 137 degrees this time. So if that angle is 137 degrees, can I figure out A and B? Here is your hint that these radii are equal. Also, this angle, according to Thales' theorem, this angle ABC is 90 degrees. That is just Thales' theorem again. Oh, sorry, no, this is not Thales' theorem. What am I saying? Sorry. This is tangent is perpendicular to radii at the point of tangency. And if I made that mistake before in the video, go ahead and correct that. Let's see. Here again, this is 90 degree for the same reason that this is my, the angle between the tangent and the radii is a 90 degree angle. Okay, so if that is 90 degree, then I know the remainder of this angle right here, I'm going to call it angle C. So C is going to be 137 minus 90 degrees, which is going to give me 47 degrees. So if that is 47, so is this angle here, because a triangle ABD is an isosceles triangle. So that base angle is also going to equal C. So that is also 47 degrees. So A, now I can figure out because I know the other two angles of a triangle. So that is going to be 180 minus 2 times 47, or 180 minus 94 to give me 86 degrees. So the measure of angle A, I'm getting it as 86 degrees. Okay, so if that is 86 degrees, can I figure out this angle B? So to figure out angle B, I can look at a couple different things. So take a minute and see what you can do to figure out what B will be. How I would do this is I am going to label, say, this angle between the secant BD and the tangent BC. I'm marking it as X. So I know X will be 180 minus 37 because 137 and X are supplementary angles. So that will give me, how much, people? So that is what I'm getting. Oh, sorry, it should be 173. Okay, so that is 43 degrees. So that angle X is 43 degrees. So if x is 43 degrees, then the tangent secant theorem tells me that this arc BD is going to be twice of that. So arc BD is going to be 2 times 43 degrees. So that is 86 degrees. So if that arc is 86 degrees, I know that B is an inscribed angle for the same arc. So that should be 1/2 of that. So that will be 43 degrees. The easier way to do it is when I knew angle A is 86 degrees, I know that arc BD is already 86 degrees. And if that arc is 86 degrees, then B is the inscribed angle for the same central angle. So that should be 1/2 of that, or 43 degrees. Okay, let's move on to the next one. Okay, so here I can see that this angle, angle EMN, is given to be 3x plus 4y. So that tells me that this arc EM, the measure of arc EM, is going to be 2 times 3x plus 4y, and this is my tangent secant theorem. So that is 6x plus 8y. Now, if we look carefully, this angle, angle A, is the central angle for the same arc EM. So this 7x plus 6y has to equal 6x plus 8y. If I simplify that, I will get x equals 2y. So all I've done is I've subtracted 6x on both sides and also subtracted 6y from both sides to get x equals 2y. Okay, now I can see that I'm getting a system of equations. So let's try and figure out the other system of equations that I can use. I also know that this angle is 65 degrees and triangle AEM is again an isosceles triangle because the radii are equal. So this is also 65 degrees. So that tells me that 7x plus 6y plus 65 should be 180 degrees because these are sum of angles of a triangle. Or 7x plus 6y equals 180 minus 130 degrees. So 7x plus 6y is 50 degrees. I have two equations now, equation 1 and 2. I have a system of equations. In this case, I can solve it by substitution. So for x, I'm going to substitute 2y plus 6y equals 50 degrees, giving me 14 plus 6y equals 50. So 20y is 50. So y is 5/2 or 2.5. Now, if I go back and substitute this, so my x is going to be 2 times y, or 2 times 2.5. It is 5. So my final solution is x is 5 and y is 2.5. Okay, moving on then to number 5. Okay, I am looking at a lot of angles and a lot of angle measures that are given to me. So I am going to start by looking at what I know. So I know this EG is going to equal GB, because these are tangents, two tangents from an exterior point to a circle are equal. Similarly, GB is also equal to BF. So I know that triangle